this revision is coming quite late. So, but then I'm going to go through all the experiments and then to shed light on the most important things you should be looking out for during your CBT. And then if you haven't got your exam card, try to get them as soon as possible, or at least get a written note in order to get to sit for the exam. And you'll be given a slip. A slip would contain your registration number and will also contain a 4-digit number which would serve as a PIN, because you would need your registration number and a PIN that will help you to get access or gain access to sitting for your CBT. And then please also get your own calculator. There is no way you would run away from calculations. You're going to be doing a lot of calculations and all of that. So okay, we started with experiment 1. Experiment 1 had to do with weighing with different balances. Okay, you were exposed to 3 different weighing balances. We have the triple beam balance, we have the analytical balance, and we also have the balance that is called the top loader. All right, so amongst the 3 of them, the most accurate and the most used and the very much most reliable is the analytical balance. Okay, so and then we have the least, which is the triple beam balance and top loader. And in the previous videos, you should look out for how to calculate amount in grams of a given substance. Okay, and that I've explained in the previous video. Know how to calculate amount in grams. Amount in grams, know your formula, that number of moles equals amount in grams divided by molar mass. So you could be given the number of moles, and then from the substance or from the compound you're given, let's say sodium hydroxide, NaOH. So from there you can actually get the molar mass. All right, because you know sodium is 23, oxygen is 16, hydrogen is 1, carbon is 12, sulfur is 16. So all these values are constant. You are supposed to know unless it's given. If it's given, it would help you. All right, so know how to calculate amount in grams. And amount in grams, from the formula, number of moles equals amount in grams divided by molar mass. So once you summed up all the atomic masses of the individual elements in the compound, you should be able to get what is called the molar mass. So if you're given the number of moles, all you have to do is cross multiply, make amount in grams the subject of the formula. So that means amount in grams is number of moles multiplied by molecular mass or molar mass. All right, so you should be able to know how to do that. And then if, for example, you were told maybe benzoic acid, and then you were not given the compound, you should know what benzoic acid is. Benzoic acid is C6H5COOH. So from there, you should be able to get the molar mass, knowing fully where the atomic mass of carbon is 12, hydrogen is 1, oxygen is 16. So when you do all the summation, you should be able to get the molar mass. That's essentially how to get the molar mass before you use the number of moles equals to given mass or mass in gram over molar mass to find probably the amount in gram or the number of moles, whichever be the case. So if, for example, you had a value and that value says, let's say 14.245, and then you asked, let's say, for example, what instrument would be used to measure such a value? You should know that the analytical balance is the most accurate and should be able to measure precisely that particular value. And let's say, for example, you want to measure 40 grams of sample. 40 grams, exactly 40 grams. So it is actually convenient for you to use the triple beam balance due to the readability. And let's say you want to measure, let's say 40.25, you should know that the top loader balance could measure that because of the readability. Okay, so anything, let's say 14.2456, analytical balance based on the readability. All these values I've just stated, you can write them down, observe those values, and see why. You get to know that this analytical balance can read up to several digits, okay, more than the top loader, while the top loader can read more than the triple beam balance. So the analytical balance is better than the top loader, the top loader is better than the triple beam balance. So it only depends on your choice or availability, or which weighing balance that's available for you to use. So that's all about experiment 1. Experiment 2, that was primary standards and preparation of standard solution. Know what a primary standard is. What is a primary standard? That's a substance with very much high purity. Okay, it can be used to actually determine the concentration of other substances. All right, so they are very much high purity. All right, what's even a standard solution? Solution of known concentration. If I say 0.5 molar sodium hydroxide, that means sodium hydroxide, the concentration is known to be 0.5 molar. You see, so that means 0.5 molar sodium hydroxide is a standard solution. So a solution of known concentration is actually a standard solution. You could be asked, who knows? Okay, so you should know what a primary standard is. That's a substance of very much high purity, and it is very, very stable. For a substance to be to serve as a primary standard, it has to be stable. All right, and it does not have to contain water of crystallization or water of hydration. Okay, so these are just a few characteristics of a primary standard. And then, how do you prepare these standard solutions? So if you refer to the previous videos I've made, you get to see how to prepare a standard solution. If, for example, you were asked to prepare, let's say, 0.01 molar solution of sodium carbonate, how would you do that? So know how to calculate, know how to prepare, how to calculate the amount in grams to be used in preparing a standard solution, because that's what it means. So you have to convert, let's say 0.01 molar sodium carbonate. How much in gram would you need? Maybe in a given volume, all right? So know how to do that calculation very well. I think I've made a video on that. You can refer to that to know how to calculate that. It's very important to know how to calculate the amount of substance needed to prepare a given standard solution. And for convenience, if you want to convert, don't forget that 1 dm cube is equivalent to 1000 cm cube. And 1000 cm cube is same as 1000 ml. And then you have to know that 1 liter is 1000 cm cube. All right, 1 liter is also equivalent to 1 dm cube. All right, so with that in mind, you should be able to know how to convert between different volumes, because these are volumes. Volumes are measured in cm cube or in liters or in mil. All right, so these are units for volumes. You should know the units for concentration, so that once you've seen it in a question, you'll be like, okay, I know this value is talking about concentration. Let's say, for example, you saw a question that says 500 cm cube, 0.05 molar sodium triisonitrate 5. Sodium triisonitrate 5, NaNO3. Now, 500 cm cube is the volume, 0.05 capital letter M, which is molar, is the concentration. If you don't see capital letter M, you can actually see mole per dm cube. Mole per dm cube and capital letter M are all units for concentration, molar concentration. So you see what I mean? So with that, you should be able to know how to use your formula. Very important, you have to know these formulas. Molar concentration equals mass concentration divided by molar mass. Molar concentration in mole per dm cube, which is molar, equals what? Mass concentration, what's the unit? Gram per dm cube. Molar mass, what is the unit? Gram per mole. So with all these units, you should be able to know. If a question pops up, okay, you bring out the data, you be like, okay, this formula will suit. You just input them, make subjects of the formula, all right? And how to calculate molar mass, I've talked about that before. Now, if, for example, you were asked to, let's say, calculate the amount in grams required to prepare 350 cm cube of 0.05 molar NaNO3, how would you calculate that? So first of all, if you look at that question, you get to see that molar concentration is given, which is 0.05 molar, which is capital letter M. Now, for the fact that the compound is given, NaNO3 automatically tells you can actually get the molar mass. Can you see that? So now, the first thing you're supposed to calculate in order to find the amount in grams required to prepare such a solution is to find what is called the mass concentration. And from the formula, molar concentration equals mass concentration divided by molar mass. Make mass concentration the subject of the formula. That will be molar concentration multiplied by molar mass. So what is the molar concentration from the question? 0.04. What is the molar mass? You do all the summation of the individual atoms in the compound. Alright, sodium is 23, nitrogen is 14, oxygen is 16. So you do all the summation, whatever you get is the molar mass. Then you multiply the molar concentration, 0.04, by whatever value you got when you summed up. So whatever it gives you is the amount in gram per dm cube. So you go back to the question again. How would you prepare 350 cm cube? So you got an answer that says 3.4 gram per dm cube as the mass concentration. So that means 3.54 gram per dm cube actually means 3.4 in 1000 cm cube. So you can just write an arrow. You could just write 3.4, put an arrow, 1000 cm cube. So beneath 3.4 gram, just put an X. How much will be in 350 cm cube? Then you cross multiply. Whatever answer you get is the amount in 350 cm cube. And that is how you prepare 350 cm cube, 0.04 molar sodium triisonitrate 5 NaNO3. So if you actually if you have actually taken this down, you get to see that it's actually easy. You can actually do it for any question, depending, or if you're asked to find the amount in gram and that question pops out in that order. Now let's look at experiment 3. In the previous video that I've made, experiment 3 had to do with standardization of sulfuric acid, H2SO4, with sodium triisocarbonate 4. Alright, like I said earlier, you should know how to balance chemical reactions and all of that. And you should also know your formulas, as I've been saying. Now, in that experiment, you were actually required to find percentage purity. That means you should know the formula for percentage purity. Percentage purity is mass in gram per dm cube of the pure substance divided by mass in gram per dm cube of the impure substance. So based on the question, if you're given all these values, then after dividing, multiply by 100. Whatever it gives you is the percentage purity. And don't forget the acid goes into the burette, while the base goes into the conical flask. And then depending on what acid or base you are served, also remember that a strong acid and a strong base, any indicator can be used. For a weak acid and a strong base, phenolphthalein indicator can be used. While for a strong acid and a weak base, methyl orange can be used. So don't forget your units, they are very important. And usually in neutralization reaction, for us to get concentration of an acid, okay, to calculate, we make use of the formula that says CAVA over CBVB equals to A over B, if you've not forgotten. So, and you know how to make use of those, how to compute them, knowing their unit. Volume is measured in cm cube or dm cube based on the question. Concentration is measured in molar, that's capital letter M, or mole per dm cube. And from the balanced equation, you can actually get your A to B ratio. Your A could be 1, your B could be 2, based on the balancing of your equation in the neutralization reaction, if you've not forgotten. So you should know how to balance aside redox reaction. I've actually explained all of this experiment in the previous videos. So this is just going to serve as a recap. So try to refresh your mind on all these things. Take down the whole note and go through them. Pick those things that are very much important and know how to calculate their molar mass. Alright? So if, for example, you were asked maybe what's the molar mass of, let's say, CuSO4 dot 5H2O, that is copper sulfate pentahydrate. So whichever be the case, you see a dot means plus in chemistry. Okay, all you have to do is sum the whole thing up. All right, so and whatever you get is the molar mass or mountain gram of that particular substance. All right, so we will not be going into the major calculations. Like I've said, we've done this calculation in the previous videos. And then you might be asked, maybe mass in gram. How would you calculate mass in gram per dm cube? All right, how do you do that? Remember the formula earlier I've said, molar concentration equals mass concentration divided by molar mass. Molar concentration is measured in mole per dm cube, or capital letter M. Mass concentration is measured in gram per dm cube divided by molar mass is gram per mole. So that formula alone can help you, go a long way in helping you do a lot of calculations. All right. So, and that is about that experiment 3 and including experiment 4, because experiment 3 and experiment 4 are all related. The same set of formulas, the same set of reaction, that is neutralization reaction for both. And then experiment 5 had to do with determination of the molar mass of oxalic acid and its water of crystallization using potassium permanganate. So that was a redox reaction, because reduction and oxidation processes are taking place. And I've actually explained what oxidation means and what reduction means. Based on the chemical reaction, you can actually tell if oxidation is taking place or if reduction is taking place. All right, so what is oxidation? Addition of oxygen. Once you've seen that there's an addition of oxygen, that's oxidation. Oxidation actually means removal of hydrogen. All right, so oxidation also means increase in oxidation state. So the opposite is reduction. So oxidation, addition of oxygen, removal of hydrogen. All right, increase in oxidation state, and oxidation is the process of electron loss. So you have to understand all of this. Okay, so basically potassium permanganate, all right, and oxalic acid were used in the redox titration in experiment 5. And potassium permanganate itself is an oxidizing agent, potassium permanganate, while oxalic acid is a reducing agent. So you have to know what an oxidizing agent is. I've also explained it in the previous video. So, and how to balance these redox reactions. You have to know how to balance the redox reaction. That could actually help you, just in case something related to balancing redox reaction comes up. So you should also know how to balance redox reaction. And in the redox reaction, in the redox titration, if you could remember, no indicator was used because potassium permanganate is colored. It's actually purple in color, so there was no need for the use of an indicator in the process. So what happens at the endpoint is that you have a colorless endpoint, and that colorless endpoint is due to manganese 2 ion. All right, so from manganese 7 to manganese 2 ion, because the oxalic acid, being a reducing agent, reduced the permanganate from the +7 oxidation state to the +2 oxidation state in an acidic medium. All right, and don't forget that hydrochloric acid is not actually suitable for the acidification. Instead, we used sulfuric acid. So hydrochloric acid is not suitable because it reacts with the potassium permanganate, and that is why we never used the hydrochloric acid. So hydrochloric acid is not suitable, but instead we made use of the sulfuric acid. Let's take, for example, if you should write down ion 2, that is Fe2+, and giving you with an arrow Fe3+ +1 electron. If you look at that, you get to see there's an increase in oxidation state from +2 to +3, which is oxidation. You see, that is an oxidation process. So basically, you should look at the previous videos for places you are not really clear and take note and get to understand some of these things that we've done in the experiment. So, and experiment 6, which happened to be the last experiment, had to do with the determination of calcium in a limestone sample. So I'm basically going to shed light on some of the reagents that were used. Okay, silver triisonitrate 5 AgNO3. Okay, a solution of silver triisonitrate 5 solution, that's a solution, was actually used to test for the presence of chloride ions. That is what we use silver nitrate to do, to test for the presence of chloride ions, because the silver nitrate can actually react with the chloride in calcium chloride to form silver chloride, which is a white precipitate. All right. So the formation of silver chloride is indicative of a white precipitate. So, and ammonia was also used in the determination of calcium in limestone sample. What was the function of the ammonia? The ammonia was used to neutralize the hydrochloric acid in the solution, which changed the color of the mixture from pink to orange. All right. So, and what else? The oxalic acid precipitate. Remember, we were after the calcium, all right? So the calcium oxalate precipitate was titrated against potassium permanganate, which was a redox reaction. Okay, so basically you should know how to balance this redox reaction. It's actually cool when you get to understand. So this is actually going to serve as a brief talk on some of these things, so that you go back to these videos and understand how to do all of this, because everything is very much important, especially calculation. You can't escape that. So good luck in your CBT, and don't forget your exam card